In this section, we're going to look at how we can use the same tools that we've been using in the last few modules to actually predict with an encrypted neural network on encrypted data. So what I have here first is just a very simple kind of canonical PyTorch model. So I've got, sort of a custom neural net with a few layers and some nonlinearities, and I've got sort of a simple XOR data set, kind of for propagation logic, and then an optimizer and a training loop, right? This is sort of, if I were to write a hello world for PyTorch, it would probably look something like this. And we can train it, and we create a model. It does pretty well. We can predict this model on the data, and it does pretty good. So it's supposed to predict 0, 0, 1, 1, and it predicts 0, 0, and then we could train it longer. It'd probably fit more. But yeah, so here we have a prediction. And what this module is about is about showing you how to use the same tools you've been using before to encrypt the model, encrypt this data set, and then run the prediction while it's encrypted. So the first thing we want to do is encrypt the model. So we're going to say encrypted. Oh, and note, this is in the same context that we were running the previous demo, so we still have several workers running. We still have Bob, Alice, and secure worker. So we have encrypted model equals model.fix precision. So right, so we need to take all the parameters and encode them in fixed precision because we want to operate over decimal numbers, right? All the weights of the model are decimal numbers. Share Alice Bob crypto provider equals secure worker. Cool, now we just encrypted our model, just like that. And in case you didn't believe me, we can look at encrypted model.parameters, and it's a big list of, fixed precision tensors that are also have additive sharing tensors under the hood. And it's shared between Alice and Bob. And the crypt provider is secure worker, as you can see. Okay, cool. So we got the encrypted model. Now, let's run a prediction. Actually, I'll leave this here, just so it's nice to look at. Encrypted data. Oh, we've got to encrypt the data first. So encrypted data equals data.fix precision .share Alice Bob crypto provider and then so encrypted data. Awesome. And let's encrypted prediction equals encrypted model encrypted data. Boom, just like that. And let's look at the prediction. .get .float precision. And just like that, the same results, a little bit of rounding error, but largely the same results as we got from the sort of decrypted model. However, when this prediction happened, it was shared across multiple individuals. Now, why is this demo so vitally important? This encrypted prediction powers a new kind of application called encrypted machine learning as a service. And encrypted machine learning as a service basically just acknowledges that if, say, Alice was the data owner and Bob was the model owner, then that means that Bob could allow Alice to use his model to predict without Bob ever seeing Alice's data and without Alice ever seeing Bob's model. Let me put this another way. Let's say that you had a machine learning model that could do machine translation. It could translate English to French, right? And let's say Bob had this model. So Bob has this neural network that can translate English to French. This means that Alice could show up with an English sentence and have Bob's model translate it into French without ever revealing to Bob what the sentence is, without ever Bob being able to read either the English version or the French version, right? More importantly, or maybe as importantly, Bob never actually has to reveal any of the neural network parameters to Alice, meaning Bob's IP is protected. So Alice's privacy is protected while Bob's IP is also protected. Cool? Or if you thought, let's say you had some sort of image classifier, like an image classifier that could perhaps identify whether a picture of your arm that has like a mole on it, has cancer on it or not, right? this would allow this classifier to classify this image without the image ever being able to be viewable by anyone else, without the image ever being sent anywhere, right? Because the image, from the data provider is MPC shared. It's encrypted, right? Before the computation is run, and the output by default is also encrypted and is only decrypted by the data owner, right? So this notion of like encrypted machine learning as a service means that as it matures, it offers the potential for machine learning providers to no longer need to require data to be uploaded to wherever the model is, or for the model to be downloaded in order for the service to be performed. It's a really, really exciting use case. And actually, as such, in the next demo, we're going to do this one more time with a sort of different model and a different data set. So I'll see you then.